Now, toward that end, we have a very important project that we have been talking about at the last couple of ocean forums, which is the Ecological Marine Units Project. Now, this project has been launched here at this meeting, and we've given you progress reports on the Ecological Marine Units. It is now officially launched. It has been published in the peer-reviewed literature. We continue to add to this project. And so, in that spirit, I want to introduce to you one of the co-leaders of the Ecological Marine Units, my colleague Sean Breyer, one of our leaders of the Living Atlas of the World. He's going to talk to you about one of the next phases in the Ecological Marine Units project, and this is about higher resolution EMUs. And then Sean will give way to Roger Sayer, who will tell you about an even further step, which is moving the ecological marine units further to the coast to form ecological coastal units. And that will, in fact, tie to ecological land units. So this is what we call total world domination in a very good sense. But now I'd like to introduce to you Sean Breyer. So Sean, take it away and tell us about higher resolution EMUs.
Thanks, Don. So I'm hoping most of you have heard about ecological marine units already, but if not, what I've done is shown you sort of this is the link to the website. And in this site, you can actually learn a lot about what we've done and some of the science behind the work we've done. But the goal was to create a 3D ecosystem map of the world. And in doing that, the first feedback that we've got has been really positive. So there's been a lot of good opportunities to show this and share this with the world. And one of our goals was in that concept of a web GIS, and the web platform is to make this data openly available. So we've done that, and you can see on the website where to get to that. But what we found was the idea of the ecosystem, or the EMUs, was to create a globally consistent ecosystems map. And in doing that, we were able to move and create this 3D map. We can move into an area. We can click on the map and we can actually learn about that location. And in this case, we're looking at a mesopelagic, very cold area with euhaline. So you get an idea of the characteristic of that location. But in doing that, last year when we launched this, the first thing that came to question was, well, I actually work in Monterey Bay. How can EMUs help us? And really, they were built for this broad understanding, but the concept of being able to localize and take more local data to that area and create a localized EMU was something we sort of aspired to last year. And in doing that, here's an example of where our EMUs are located today. But behind the scenes, what we used is the World Ocean Atlas to supply us with the data for the world. Behind the World Ocean Atlas is actually a World Ocean database, which is millions and millions of in situ points over 50 years. So what I'm going to do here is actually just turn on some of that collection data. So here you're seeing the two dots near the bay are the EMUs, but here's all the input data that went into finding those quarter degree points. Wouldn't it be nice if we could actually do a more localized EMU with high resolution that a local researcher could use? So what I'm going to do is actually move in here and show you exactly what that looked like. Take a second to refresh. Let's get to our scene. There we go. And in just a moment here, what you're going to do is you're going to see the work. What we've done here is take that high resolution local data and grid it. Now, this was the first step to prove we could do it, but the next step was how do we make it useful to the larger audience? So the NOAA Select has a capability to zoom into any area of the world, extract all the information like we did for the Monterey Bay area. And then what we've done is using Pro, we've created a taskbar, and that taskbar will step you through the processes from all the way from the conversion and the download of the netCDF files through to creating this cluster analysis and creating the 3D representation of your ocean area. And in doing that, we allow you a lot of flexibility. So the data we've worked on so far has been all historical decadal 50-year averages. This is an example of data that was taken over a 1 to 2 year period and then summarized. So we can actually start looking at higher resolution, specific times a year, and then also creating these great 3D meshes that you can start to do analysis, look at change over time, look at the EMU changes over time. And this is just a step in the right direction of creating this localized system and availability of this mesh. The goal is to, on our website, have a launch of this capability of building your local EMUs by January. And that time you're going to have the access to this task capability. We're going to have some explanation on how to download the data from NOAA, and then you can create your own localized EMU with your own data. So that's sort of where we're heading right now with EMUs. We're definitely going from this very low resolution to this hyperlocal. And it's just sort of the beginning point for us. The next thing that's going to be moving on is the ECUs, or the coastal units. And next we've got Roger, who's going to come up and tell us sort of about the last 2 days of meetings that we've had around ecologic coastal units and where those are going to head for us.
Thank you. Hello, everybody. Great to be here. I'm that guy behind the mask. I'm really here just to let you know that over the past 2 days, we had a very successful meeting where we have launched a project to identify global ecological coastal units. And I'm just going to tell you a little bit about that. And they follow on after the ecological land units work that USGS and Esri and others have done, and then most recently the EMU work, which has been so well described already. And thanks for everybody who came before, who set such a wonderful spiritual stage and inspirational stage. And Dr. Sullivan mentioned that, you know, these SDG goals are becoming the driver for everything. So if the work that you do doesn't really support one of those SDG goals, then you better start following the puck, as it were. They're really important, these SDG goals, to frame our work. And we saw a video this morning about GEO and Esri's relationship with GEO. And the work that we're doing together is from the GEO, which is a consortium of over 100 nations, the Group on Earth Observations. They have an agenda, they have lots of tasks. And there's one that I lead, that the USGS leads, from the Geo Ecosystems Initiative, which is essentially to map global, standardized, robust, practical, global ecosystems for freshwater, terrestrial, and marine environments. We are working through that charge. We have, as mentioned, produced already global ecological land units, great piece of work at 250 meter spatial resolution for the planet. That's a wonderful resource there. And then, as Don has mentioned, we've just released the EMUs, and we've seen that they have a global instance, and now, because people want local EMUs, then Sean and his team have figured out this fantastic way for you to create your own EMUs for your area of interest. So tremendous work there. Then looking forward into the charge now, the ELUs arrive at the coast and the EMUs arrive at the coast, but neither of them treat the coast sufficiently because it's such an important area, the true land-water interface. Humans are everywhere. Everything's going on there. So we have launched an effort to map standardized global ecological coastal units, which means we are going to quantitatively segment the coastal zone into environmentally distinct, ecologically meaningful areas. We are starting to get a project mascot. We had them for the other two efforts. This is a sand crab. I love sand crabs. I am still digging for them when I go to the beach. And I just learned that its genus is Emerita, which must mean it merits, which is great because this work is merited, certainly. We're going to start with a new product that we have just generated called a global shoreline vector. It is a 30-meter new coastal shoreline product interpreted from 2014 Landsat imagery. It's Still has a little bit of work to do, but when we finish that work, it will be better than any of the existing public domain global shoreline maps. So we'll be using that. The first thing we had to do as a group is sort of bound the universe. What are the coastal geographies that we're talking about here? And we are going to sort of map 3 subzones. On the land inside, we're going to be mapping coastal land areas. And in the water outside, we're going to be mapping nearshore coastal waters and offshore coastal waters. And how are we going to do that? We're still sort of figuring out exactly how we're going to do this, but we're arriving at this notion of using data-derived boundaries. And so the thickest line in the middle is the coastline. And then the dotted green line inland, that is the extent of the coastal plain. And we have modeled it properly with DEM data and landform modeling. And so we have a map of the coastal plains of the planet. And it is a place where there's a channel called a thalweg, I just learned that word. It starts to rise, and that's the beginning of the coastal plain. So we have mapped out the coastal plains, and we will map ecological coastal units in those coastal land areas. And then on the water side, we're separating out the sort of very shallow, the nearshore or neritic coastal waters, and we're going to map out to the shelf edge, and that area between the nearshore and the coastal edge we're going to call the offshore coastal waters. So those are the 3 subzones. What we're going to do inside them is statistically identify distinct abiotic settings in combination with matrix-forming biological assemblages. And we're going to do the analysis within each of those subzones. And how we're going to do that is we're going to establish these transects at scientifically defined intervals, segments along the shoreline, and we're going to draw a transect from the shoreline into that coastal plain boundary. If it's not a coastal plain right there and it's a mountain rising up from the ocean edge, then we'll just go in a little bit so that we can make sure we capture those pesky birds and other things that actually have their rookeries on the cliffs and whatnot. But we will extend that transect into the coastal zone boundary and out to the offshore edge. And then we will populate those transects. Those become our spatial analytical units. Populate those with data. We'll have to find exactly what data, and some of this part is data-driven, depending on what's available, but we will get globally available data that matters for the controls on the biotic distributions, if you will. We'll take the data, we will populate it onto these transects, or profiles, if you will, and then we will cluster all of those profiles to identify these abiotically distinct areas in combination with their biological assemblages, those being mangrove salt marshes, coral reef seagrasses, kelp beds, and, did I say oyster? Shellfish communities as sort of matrix-forming biological assemblages. That's what we're going to do. We still have a lot of work to do to really refine that methodology. Maybe next year we'll be showing you some great maps of ecological coastal units. And so at this point I would say wait for it on the ecological coastal units, but I'm actually going to go farther out following the puck and say wait for it after the ECUs we're going to work together to make a map of global ecological freshwater units to sort of finish out those domains of terrestrial, freshwater, and marine. Thank you very much.